Hello, everybody. My name is CSO Justin Kandiri. Welcome to Chief Science Officers Zoom In on Science Calls, where we learn about STEM professionals and leaders. Here today, we're going to meet Mr. Omar Alam. He is a STEM engineer. He works as a member of technical staff, space systems, and Viasat in Arizona to zoom in on science, specifically engineering. Welcome, our guest, Mr. Omar Alam. Mr. Omar, I just wanted to say, please, Mr. Omar, thank you very much for being here. We really appreciate it. And thank you very much. Please tell us about yourself and about your job.
Thank you, CSO Hassim, for the introduction. I prepared a slide deck here. Should I share it? Yeah, I see the share screen button here. Thank you again for the introduction. Just so everyone is aware, my name is Omar Alam, as CSO Hassim kindly introduced me, and I'm an engineer at Viasat here in Arizona in the United States. I see we have a lot of international CSOs here on the call. That's wonderful. And let me tell you about myself and my job. So I was born in the United States in Minneapolis, Minnesota, in the far north, where it gets very cold. This was 25 years ago in 1995. And I lived there until I was 18. I went to Neil Armstrong High School in Plymouth, Minnesota, and I studied a lot of math and science during high school, which allowed me to get into Cornell University in upstate New York. It's one of the Ivy League schools up there with Harvard and Yale, and I was so grateful to have been enrolled and accepted, given the situation I came from back home. And I decided to continue my passion for STEM and study physics, specifically this program called Applied Engineering Physics, which not only gave me a broad understanding of physical concepts, but also how they're applied to engineering and how I can become an engineer with a physics degree and not necessarily a specific engineering degree. I studied at Cornell for 4 years, 2013 through 2017, upon which I graduated, and then I moved all the way down to the southwestern United States, right here in sunny and warm Arizona. And I came here to work as a RF engineer, and we'll get more into that in the next slide. So an RF engineer, RF stands for radio frequency. Radio waves are everywhere. I'm using a radio signal from my cell phone right now to send a radio signal to the cell tower, and it carries my voice so you can hear it. The Wi-Fi on your computers are using 2.4 gigahertz radio signals to pass all the internet activity back and forth. So RF engineering is a broad field, and what I work specifically in is satellite communications. The satellites are launched into space from companies like SpaceX. I actually started my career at SpaceX in summer 2016, working for Elon Musk. If you've seen the SpaceX videos, you see that the rockets get launched up into space and they actually come back and land on a boat or on the ground. And I worked on that rocket landing system, which uses a specific radio frequency device called a radar to bounce radio waves back and forth from the boat, and it tells you how high up the rocket is as it's approaching for landing. So I did an internship there, but I decided to pursue a full-time job here at Viasat in Arizona, and I work on the whole portfolio of radio frequency products at Viasat, from the actual space satellites themselves to our in-flight Wi-Fi systems and our residential terminals. Very briefly, satellite is sending these radio signals back and forth from space. That's collected by this satellite dish antenna on the side of your house. And then the dish antenna goes out to your modem or your Wi-Fi router, which then provides the Wi-Fi network. So I'm involved in a lot of that. And on a day-to-day basis, I work with both hardware and software. So I'm grateful to be in a position where I get exposed to a little bit of everything. On the software side, I program in two main languages, Python and C#, and I write code that programs the radio frequency devices to do their thing, and I double check that the RF devices were designed as intended. Are they sending the right signals, the right power levels, frequencies, and all of that? And it's very fun to be working on the software side. Now on the hardware side, I get to be hands-on with and actually design circuit boards like the one you see here, and they actually take in these radio signals that are coming to and from the atmosphere, and they're processing the radio signals on their onboard computer chips and PCB traces. And you can do cool stuff like measure the antenna patterns, so how much signal is coming out from an antenna that's connected to the board. And I use equipment like this shown here at the bottom right, signal generator spectrum analyzer, which allows me to process these complicated radio signals and bring them down to a level where I can understand, are they working properly? I hope that was a one slide, good introduction to RF. Certainly feel free to ask me more questions there when we get to that point. But I'd like to move on to something relatable, and that's you guys. You're the Chief Science Officers, SciTech Institute. I've been involved with you guys for a very long time. I moved here in Arizona in 2017. One of the first people I met was Hope Parker, who's actually on this call, and she got me connected with everyone in Arizona who works on SciTech and CSO programs. Over the years, I've done a lot of work to support you guys. I've volunteered over 730 hours to support CSO and SciTech programs, and I'm responsible for getting Viasat to donate over $20,000 to both the SciTech Festival and the CSO programs, and it's a passion I have to support you guys. You'll see two pictures here. Of all the initiatives that you guys do, I'm really impressed by RAIN, the Rural Activation and Innovation Network. I love to support the rural and remote communities in Arizona, and I had the chance to visit two of them. The bottom left here, the Cochise County Leadership Institute, where I worked with the Cochise County CSOs and taught them some STEM and engineering topics. And then on the bottom right, Verde Valley, which is the Cottonwood-Sedona area in more northern Arizona. And I worked with them to teach them about how satellite communications work and how they can get involved in an engineering career. So that's all I have for my slides. I kept it pretty short so I can focus more on questions and helping you guys out. So I'll bring it back to you guys for now.
Mr. Omar, thank you very much. I really appreciate it. And of course, I have prepared 3 questions to ask you. Before scrolling the chat box, I just wanted to ask you 2 questions. The first one is, who was your mentor when you were a kid? Who did you look up to, and who encouraged you to be an engineer?
That's a great question. Thank you. There's one teacher who stands out to me the most. Shout out to Mr. Jeff Schreifels from Neil Armstrong High School in Plymouth, Minnesota. He was my advanced chemistry teacher, and I was always curious about science and math and engineering, but Mr. Schreifels always encouraged me to think one step further. He encouraged me to think, there's these chemical reactions that come together and they produce, 2 molecules coming together, they produce effects. But what's really going on? What are the laws of physics that govern how 2 molecules come together and interact with each other? He always wanted me to ask those fundamental questions, and it's because of him that I'm where I am today.
That's very cool. Thank you. The second question is, of course, I am a 14-year-old, and I just wondered, what advice would you give for a 14-year-old or any CSO, maybe anyone that's a 14-year-old? What would you give for a teenager, maybe?
Absolutely. That's a great question. I think on the STEM side, what you're doing at the CSO program is wonderful, and you guys are really going out there in your communities and making an impact. But if I was a 14-year-old, I would tell myself, work hard, but also cherish the moments when you're not working. Have fun, spend time with your family, with your friends. and really make time for yourself in addition to the great STEM work that you're doing. So there's a lot that goes into being successful, but at the end of the day, you need to take care of yourself as well.
Of course, thank you very much. Okay, so now I am scrolling the chat, and I see that Miss Kelly from CSO International comes up with a question that says, what suggestions can you provide CSOs to find an internship in their area?
Absolutely. Internships are a great way to learn about what the real world is like in science or engineering or otherwise, and I highly encourage it. If you guys haven't heard of LinkedIn before, it's this online platform where business and STEM professionals can come together and connect, and you can make a list of all your accomplishments and all your past positions. And LinkedIn.com is a tool that corporate recruiters look at when they're searching for interns. So I would make a LinkedIn profile and also network, find engineers, find scientists who inspire you. You'd be surprised at how many people, such as myself, if you just reached out, or with the CSO program, you'd say, let's schedule a 30-minute call so we can talk. I can talk about my story and how I got to where I am. And networking will make it such that when a person is hiring for a position, they're going to think about that phone call they had a couple months ago, and they're saying, hey, I remember this motivated student. I'd like to get them involved with my projects. So those are the two suggestions I have.
That's very nice. Thank you very much. A question from CSO Haley from Oregon. She says, could you talk about your work with programming in Python? I am trying to learn.
Mm-hmm. Absolutely. Python is a great language for beginners. When I was at Cornell, I actually took a first semester freshman course on Python, so that helped me as well. But I use something called object-oriented programming, or OOP, and you might have heard of that if you've studied programming. But what it allows you to do is make a base template for your code. Like, let's say I want to make a code that programs a smart toaster and a smart IoT smart home. But I want my code to be used for 2,000 toasters. So if you sell 2,000 toasters, each of them are going to come with the code, so they can connect to your Amazon Alexa and say, you know, like, Alexa, turn on the toaster or turn off the toaster. What I can do in Python with object-oriented programming is make this template and say, I have this object, or a class rather, called a toaster, a class toaster, and I populate it with different properties, like this toaster has a button that tells it to turn on to the power outlet. It has a button that turns it to turn off. It has a lever that starts the heating routine, like if you put a bagel in there. And then it has a sensor that tells you when the bagel is finished. And then I can have multiple toasters come to me in my laboratory with the IoT Smart Home Laboratory. And I can use object-oriented programming to copy that template onto all of the toasters and test each of them individually. So that's a lot of information, but Python programming and object-oriented programming allows you to write code once and use it across thousands of devices if you need to. And at the satellite communication level, we're producing thousands of modules that go into space. That becomes very useful. It's a great question.
Of course, that's very nice. Thank you very much. Also, Ms. Kelly comes with a question saying, what work have you and your company, Viasat, done to support students during the school closure?
Another great question. Thanks, Kelly and everyone. An article came out recently yesterday in the Viasat, Viasat.com corporate blog for that the public can access. And we identified a community in southern Arizona in Pinal County. It's called Mammoth. And Mammoth is a community that has been around for a long time, but they don't have great internet access. We determined we could partner with the local library come into the town of Mammoth, set up a satellite dish and a wireless access point, and then have it so that students and parents can come out in their cars and, obey social distancing, and from their cars they can connect to the satellite Wi-Fi antenna and get their internet signal in that way. So we're actively looking at communities that are struggling from the pandemic, and we're looking to support them.
Very good. Thank you very much. Also, there's a question from CSO Josh from Arizona. What was your path through college to be an RF engineer? Also, is this similar to an electric engineer?
A very great question. To answer first, what was my path? I actually came into Cornell wanting to build quantum computers. So that's like in the realm of theoretical physics. I didn't even want to be an engineer at that point. I was inspired so much by theoretical physicists like Neil deGrasse Tyson and others who really popularized science, and I wanted to be like them. As I went more and more through my studies and my lab experiences at Cornell, I realized while physics at the theoretical level is very important, these are very complicated ideas that take 30, even 40 years to get used in the real world. Einstein's equations on stimulated emission of radiation in the 1920s took 30, 40 years before it became the laser, and now the laser is used everywhere. And I wanted to be more on that short-term, immediate impact to society, and I decided engineering was the route to me because it still applies physics, but there are problems on a daily basis, like how do you make satellite internet faster on airplanes? The second question was, is RF engineering similar to electrical engineering? And the answer is yes. Electrical engineering is a very broad field. It includes computer hardware engineering, like how to make Intel processors in the laptop I'm using right now, or even how to do image processing from the camera coming from my computer right now. RF is one of those very specific fields in electrical engineering that tells you how to harness the radio waves, these invisible waves that travel through the atmosphere, and how you can put like the internet signal or your voice or video on these electromagnetic waves. So hope that answered the question.
Yes, it does. Thank you very much. Also, a question from CSO Ruptik from Kenya. He says, hello, Mr. Omar. In the first slide at the bottom, you had a phrase regarding quantum physics, and I would love to understand quantum physics. Is there any advice you would give me to help understand quantum physics and STEM itself?
Yeah, wonderful question. And the reason I love quantum physics is because it really challenges how you think about the natural world. Quantum physics, like the Schrodinger equation and other formulations, they tell you, you think of well, to start, quantum physics is about the atomic and subatomic world. So atoms, protons, electrons, and neutrons. And regular physics teaches you, atom is one object where the electrons are circling around the nucleus. But then quantum physics is like, no, electron can actually be in two places at once. The electron can move around in all these different probabilities until you observe it, and then it collapses into one location. And it really challenges the way you think, and quantum physics is responsible for all of modern technology, from the laser to the computer to radio frequency technology. And even quantum computers now use RF technology. To start learning about quantum physics, I would start with regular physics, with classical physics from the basic level that's taught in high school and moving into college. It's really difficult to move into quantum physics unless you have an understanding of how physics ideas were thought of in the 1700s and 1800s and so forth, before the quantum revolution came forth in the 1920s. So I would start there, and it's math intensive. So I would practice math a lot and be sure you're comfortable with it. Once you practice math a lot and you're comfortable with math, physics becomes really fun, and you can say, hey, I can write an equation that says how I toss a ball up in the air and how gravity is going to bring it back to the ground, or how I shoot an electron from like a quantum computer, and it's going to tell me how the electron behaves. So there's a lot of possibilities.
That's very cool. It is very cool. CSO Josh from Arizona says, is there a way to name code commands?
You can, just to provide a brief answer, in programming, you can name your code and your commands anything you want. Programming is very intuitive, where the human programmer has a lot of control over what the code says, but then the computer translates it into zeros and ones. So there's a lot of room for creativity there.
That's very cool. Question from CSO Gary from Kenya says, what motivations would you give us as CSOs?
Tell CSOs first and foremost, stay true to your motto. The world isn't going to be changed if you hope things are going to happen. If you want to change the world, you got to make it happen yourself. And stay curious, stay excited, stay active, stay connected. There's a lot in the world that can be changed just by you thinking creatively and applying your ideas.
Mr. Jacob Lounsbury, what is your favorite project / most meaningful in your career?
Most meaningful project that I've worked on in my career is something I completed recently. Viasat partnered with the University of Arizona engineering seniors in their college careers to develop an off-the-grid satellite internet device. So right now, Viasat's technologies require electrical grid power. You need to plug in our Wi-Fi router and our satellite dish and all of that to, a power outlet to draw power from the wall or from the grid. But there are a lot of people in need, as I'm sure many of you are aware, and even in Arizona, in places like the Navajo Nation, even Cochise County, some of the places I've had the pleasure of traveling to and learning people's stories. Electrical power is not available everywhere, and there are people who live in places without electrical grid power who don't have access to the internet. And if they have access to the internet, they can start using the resources of the web to learn about STEM and really have an improvement in their life. And I worked with the University of Arizona and many others at Viasat to use solar panels and batteries to provide internet anywhere. You drop the satellite dish in the middle of the desert, connect the solar panels, it takes the energy from the sun, it produces your Wi-Fi signal from that process.
Yes. Okay, so I had prepared a question, and it's of course, CSO from Jason from Kuwait. I had a question prepared, and it's what characteristics is needed in this field specifically?
Great question. You need to be a good problem solver. In the physics and engineering curriculums, all your homework assignments and your exams, and all of them are very hard problems, and the college degree is very useful because that's where you learn how to solve these very hard problems. So be analytical, be critical thinker, but that's not all of it. You can't be successful just by doing math and physics alone. You need to know how to speak elegantly, how to write elegantly, and how to have these people-person skills, where the soft skills, so to speak. So not only are you a master of the technical content, can you bring the technical content in a presentation, and can you speak in front of the public who may not have learned about this topic before? So technical skills, analytical skills, and soft skills. It's a trifecta that all comes together.
Excellent. CSO Fatma from Kenya says, what was your main goal when joining Viasat? And are there any crucial lessons you learned along the way that have helped you grow as an individual?
Great question. What was my main goal when I joined Viasat? Well, I just graduated college. I wanted a job. But as I learned more and more about what Viasat was doing and the amazing things, technologies they're developing, I wanted to be part of that. Viasat wants to build satellites that provide internet anywhere in the world. And I got so motivated by that mission that I worked very hard, and I created the STEM outreach program, which allowed me to work with the chief science officers. And my goal now is to continue that mission, have affordable, accessible internet to anyone. And then crucial lessons I learned along the way that helped me grow as an individual. In engineering, this is very common. Technologies, devices, RF, satellites, they do not work on the first try. You fail 100 times until you succeed on the 101st try. Failure, don't let that set you back. Let yourself grow from it. In engineering, you're going to fail hundreds of times before you succeed, and if you keep trying every time, you keep improving, you keep understanding what needs to be improved and how you need to do it, you will eventually succeed.
Okay, so Mr. Omar, I just want to say to honor your time, we have a few more questions. Are you willing to stay for a few more?
I am. I can stay.
Cool. Cool. Thank you very much. Thank you very much. Okay, so CSO Rudra from Kenya says, Mr. Omar, did you have any problems making your company Viasat?
I can say something in regard to the outreach program and how to and people within Viasat and building that program. I created the outreach program on the side so I can support you guys like the CSOs and STEM topics. And what's difficult is everyone at Viasat is busy. Outreach is a volunteer effort for the most part. You need to take time out of your day to travel to like a school, for example, set up a booth and teach CSOs like a day in the life at Viasat or other outreach, like create demos for outreach, like if I wanted to show you how radio signals worked. And it's hard to motivate people within the company because they're busy, they have children, they're married, everyone is busy. So my advice is start slowly, but speak often. Always let everyone know what you're up to. You see a coworker in the hallway when you're grabbing coffee or water and you say, hey, I'm planning to volunteer at Armstrong Middle School in 2 weeks. And I want you to come with me because I think your perspective would be very great. Do you want to volunteer with me in 2 weeks? And just keep up stuff like that.
It's very awesome. There's a question from CSO Hamanshi. He says, hello, I actually tried to solve the Schrödinger equation in quantum mechanics, but it's somehow hard for me. It actually took me 5 hours. What advice would you give me to do better in Schrödinger equation and understand easily? Sorry if I didn't pronounce that right.
That's a great question. For a CSO, that's a very impressive attempt to solve the Schrödinger equation in quantum mechanics. Great job. And 5 hours, pretty sure it took me 50 hours. I would start with the mathematics, make sure you're comfortable with that. Watch YouTube videos. There are a lot of great people on YouTube who have a solid understanding of quantum mechanics, and they help students like you understand hard topics like the Schrödinger equation. Start with the mathematics. Schrödinger equation uses two different types of mathematics. One is differential calculus and one is linear algebra. And you cannot understand differential calculus without taking calculus. You cannot understand linear algebra without concepts like algebra and geometry. So I'd start with the basics and work your way up. I started learning quantum mechanics when I was in 6th grade, and I started slow and eventually got there. So you can do it too.
That's a very good thing. Thank you very much. Also, I'm gonna look for one last question. CSO Josh from Arizona says, does Viasat use 5G? If not, do you have any plans to use 5G?
That's a great question. So 5G is the next generation of cell phone technology. Right now, your cell phones are on 4G LTE, and then 5G is going to have much faster speeds. No, Viasat is separate. We do the space technologies. We send the internet and the data from space. 5G is using cell towers. There's discussions of partnerships, like maybe we can go to some area in need, like in rural parts of the country and the world, and use both satellite and 5G and improve the community that way. And I'm sure there'll be a lot of more discussions to come. So great question.
Thank you very much. Of course, this was the last question. Thank you very much, Mr. Omar, for being here. We really appreciate it. All of us appreciate this. You are such an inspiration to all of us, and I am the first of them. Thank you very much. Again, we thank you very much today, Omar. I can't stop thanking you because you really do deserve it. Everyone, please unmute so we can do the motto. Don't just hope it happens.
Make it happen.
Thank you very much. It was really appreciated. Thank you.
Thank you. Have a great
You
day.
did a great job hosting. You did a wonderful
Thank you very
job.
much.
No need to be
Thank you.
nervous.
I'm
Thank you,
gonna
Omar.
stop.
Thank you.
Yes, you're an excellent guest.